meetings, you know, I speak on the subject.
Got to get over to the audience, Bill.
All the time. And
over here.
what we're going to be focusing on is just a couple practical tips that you might get involved with if you're ever building a simple wire antenna like a dipole. And in the process, we're going to show you a couple of tricks that will save you a lot of time and aggravation. So one of them is the king of the knots, at least as described by some, which is, looks like bowline to any nautical guy or any Boy Scout. It's a Bolin. And extremely useful for joining antenna ropes if you made the mistake of cutting a couple of your antenna support lines. Also good for just putting, though, a terminating knot at the end of a line that you slide through an insulator and just want to fix it into place. So, we're going to be doing that, but there's also a cute little trick we're going to show you to just add to the interactive component, which, if you've never seen this, is really very fascinating and very simple, and it's how you add an extra insulator to an existing antenna. A couple reasons you might want to do that. A lot of people will start out with that design of a dipole or a Wyndham and find out they're 2 feet short on their property line. And anyone that's ever built a wire antenna can tell you that with a dipole or even a Wyndham, a couple extra feet at the end, bent down so they're going vertical, is not going to seriously impact the efficiency or the pattern of your antenna. But in order to do that, you have to be able to put an insulator on a wire that if you build the antennas, do a lot of hams, you've already soldered the insulators on. So of the 2 interactive activities we're going to do, this is the easiest. So I've actually got some insulators here. Here you go. And you will just imitate me as I do this, but if you've never seen this demonstration, it's a real riot.
I've never seen it.
Yep, here you go. Turns. Adam. And Leon will make you a victim too. You should see this. So I did spot this in an article. I think it was a Hinson Kinks article in QST. And like I say, it's a really slick technique if you've ever seen it demonstrated. And so all I've got here is a nice legacy dipole antenna. And let's just say hypothetically I'm stuck in the same situation. Watch. This is really cute. Now, the only thing is let me just see if I can post-place it. Now we're going to use this guy. So your dilemma is, we're assuming that this has been soldered. I don't always solder them. In this case, you can see the antenna wire has been pulled through the eye of the insulator and wrapped around the wire. But most hams, for a strong mechanical fit, will do the soldering. And for example, the 2 wire beams that you see, one out in the paddock and the one that was in the back lot, we do have to solder the ends in order for them to support the apparatus that they pull up the spreaders. So, if you've never seen this demo, it's really cute. Watch. You just take the wire in question at approximately the point you want to insert it. Insulator, and watch. Through the hole. Sometimes even bits. And all you have to do is go back on the other side of the insulator, like so. And there you go. A lot of people will make a triangular loop antenna that they mount vertically. If they want to convert it into a horizontal loop antenna with 4 sides, this is the way you do it. And as you noticed, we didn't have to disturb the insulator at the end of the wire. It's a really cute trick. To those of whom I gave the insulator, here comes your activity. Come up here and try it. Go ahead. But we'll have each of you do it in turn. So again, we just kink the wire, if you notice. Slide it right through. You may have to be a little bit aggressive about getting it to go through. There you go. Pull the loop through. Well, that'll work, but you really want to go on the other side. Do the length of the insulator. You got it. I'll give you a little bit more slack. No, stop. You got the right idea, but pull it out. Feed that end through, and pull. But you want, wait a minute, just stop a second. You want to pull from this end. I'll hold it, you just pull. And there you go. Cool. And it makes for a very firm connection. Let's try a couple other guys just so we can say we did it. There you go. Sure. So much for the hands-on part of this.
No, that's good.
You gotta really push.
Yep.
It's not. Is it hands-on if you use your feet?
Yeah, if you can pull this off with your feet, son, I got a job for you in the circus. Don't send them to college. You can save a lot of money.
Oh yeah, exactly. So
other side.
Other side like that.
Hold her over.
Hold her
Give
over
her a
and
good
pull.
And there you go. That's all there is to
Awesome.
it. What do we got left? We're gonna have a Christmas tree of insulators here. Give it a shot, Leonid.
Yeah, we're gonna.
So again, we just give it a bend, put it through the hole. There you go. Now pull it around, and all you gotta do is cinch it from there. And well, people occasionally ask, is this really going to affect the antenna? Marginally at the most. Probably no effect whatsoever. I will tell you though that if you know you're going to do this in a loop, and you're actually precisely carving out the length of the loop, just understand it's about a half an inch of wire that you're taking up every time you add one of these turns. So who do we have left? Turns, Adam, give it a shot. And who's left after that? Oh, that's right. This one's definitely worth the price of admission. I couldn't believe the
This
time
is
I
cool.
saw
I've
it.
never done
You
this.
could have
This is
charged
cool.
for this. Trust me.
Well, when we outlined this to the ARRL last year, is to meet the criteria, they were like, I'd like to attend this.
Yeah.
I'm the treasurer. After the meeting, I'll see you.
Which not paid active back here at Sarah University.
But you, have you done it? You've done it? No. But you get a credit against your club dues.
Oh, yeah.
Oh!
You can work in the shelter, yeah.
I can do
In
it.
just a second, I am going to discuss a little bit about parts.
I heard the clip also come with free antenna installation.
Oh yeah, it actually does.
Free antenna advice.
No, it's like an Amish fundraising. We'll all come over. You're
That's
just
true.
expected to buy a keg of beer.
Yeah. Well, and you have to
We'll
also,
put the antenna up before we drink.
and you also have to volunteer your antenna for field day for the next year.
Yes, that's the tradition. All right,
is
so everyone's
way
doing the
cool.
demo. Remarkably simple, very utilitarian, and like I say, especially when you want to add an additional side to a loop, nice thing to know. The other thing to just talk about briefly, though, is parts that would go into a standard dipole antenna. And for anyone that knows me real well, they know that I say this with pride, I'm one of the cheapest people you'll ever meet when it comes to buying components. This is a nice center insulator for dipole. Hold this in your hand for just a second, though. And what's your impression?
It's dense.
You want to guess at the weight? I don't really know offhand.
I'd say about 1.5 pounds, 2 pounds.
I like those. And in a heavy-duty installation, where you're putting up a 160-meter dipole, these are great. You also got the hanger hook. But the thing is, the eyelets allow you to wrap the rope or the wire through it several times, take some of the stress off, and the connection point to the solder doesn't have to absorb the stress. So these are nice, but they're heavy. One of my personal favorites, I only have an old piece of crap, is the Budwig. Pass these around, though, just so you can compare them. Interestingly enough, they don't differ much in price. The people who sell those Budwigs are making a nice profit, believe me, because cost of manufacture are probably $1 a pop. But there's something to be said for that approach, because it is light, it's got the same mechanical eyelet support if you want to pull up the dipole in the middle, and for long-term survival of a long dipole, especially with 160 meters, not a bad way to go. The only thing I don't like about it is, where the wire meets the end of the wires that come off the Budwig, there's a tendency for the wire to snap. In other words, you're adding a new stress point, unfortunately, because when you solder at the end, that soldered portion becomes the stress point. So it's kind of a mixed judgment call on that.
That's just an insulator, though. That's not a balun, right?
Right. And the thing is, I personally don't use balance on dipoles. A matter of personal taste, but I've never been a big believer in the concept. All right. Two other options I just want to show you, although really the next one is pretty much more of the same, is this is just a little spray-painted camouflage piece. Now, I did put up a semi-stealth antenna with Tony. And no lie, when we put it up, we did the casual. If you didn't know where it was, could you spot it? And what did we see? The white portion,
The white
the center
balun,
insulator.
Right.
One sheet can of spray paint, and it disappears. So not
That
a bad way to
antenna's
go.
over there. When we take it down, you can look at it. I just sprayed it with gray paint.
And this
Green
guy, if
paint,
you look it
all
over,
drop.
is really just a somewhat differentiated version of the one that we're circulating among you. My all-time favorite, though these guys are pretty pricey though, is this one made by High Game. God help us, now made by MFJ. So just pass this around so they can see the center insulator. That'll run you about 30 bucks. But if you're the kind of person that spontaneously puts together antennas for special needs and then rips them to pieces and puts the parts back, it's really nice because there's no soldering involved with that guy.
Yeah, it's just screws.
Goes in through one hole, wraps around the post, you just tighten the nut, and it's good to go, and it's infinitely reusable. About 30 bucks a pop. And now it's MFJ making them in the name of High Game. So, we'll see what happens in terms of quality control on that one.
These are for single band dipoles.
Yes. But I'll give you an example. Do you remember I described doing an inverted L and tweeting back in January? That's what holds the two sections of the antennas together. The radials can come out of one hole on the bottom, and the top can be used as the vertical stretch of the antenna. Alright, now we're going to come up to the fun part, which is the knot tying. So, I've got some brief lengths of rope. The only problem here is Adam, who's supposed to be one of the learners in this case, could probably teach us this move. But here, for the rest of us, just grab one of these, and we're going to talk about just one basic knot that is one of the all-time favorite for ham radio operators in general. Also fairly popular with sailors. And I'll tell you what, you can do one here. And teach it to Leonard, or Leonard. Now, Bolin tires. Am I a good Bolin tire? Yeah, when I remember how to do one. And no kidding, I go through a cycle of doing it, saying, oh, this is simple, and then forgetting it 5 times a year. But we got a couple really good Bolin tires here. So, Tony, basically Ernest. Fred can do a passable Bolin as well. So we're actually going to take a whack at doing this, but I'm going to let the guys demonstrate it to you. Ernest, though, is going to be the master tire, and he's got a kind of enlarged rope that's easy to follow. So, Ernest, why don't you give the basic approach, and then they can try it on their own.
Okay, let's say I'll go over here. The basic bowling without anything, you take the rope and make a loop. Make sure you have a tail. Now, the old saying is, with bowlings, the rabbit comes up the hole, goes around the tree, and goes back down the hole. Then you grab it on the bottom and just pull it, and now you have a loop and a knot. The advantage of this is that when you want to take it apart again, you just take this and go like that, and the whole thing comes apart. So it holds a lot of weight and tension. And the more tension you put on it, the tighter it gets. It won't let loose. And that's the basic. So if you wanted to have a rope and you wanted to make a loop at the end of the rope, you take it, loop it, make sure that the hole is, the tree is behind the hole, come up through the hole, around the tree. This cord is not as flexible as we'd like, but we can still do a bowling. And that's the bowling.
And I'll just tell you a casual conversation.
That will give you a loop. And you can make the loop large or small, depending on what you're tying off a boat on a big cleat, and you want a temporary loop. Let's say you make a big loop, so you'd make it longer. Now, the next thing you want to do is, if you want to tie on an insulator, and I don't have an insulator that'll take this, but if you wanted to tie around something, you go around the. Let me go the other way because it's easier. You go around the object. Now you've created your hole and the tree. Up the hole, around the tree, back down the hole again. I gotta find the right ones to pull. There it is. And now if this were the hole in your insulator, you'd be holding on to the insulator. Again, when you take it down at the end of the day, on field day, you want to get this off quick. You don't want it, so you just peel it open, and you're off the insulator. So that's the way it works. Now, I think for all of you, you don't have an insulator, but if you learn the basic thing, it's just a matter of putting the loop, you're putting the rope through the hole, and then figuring out where to put the loop, the tree, and tie it off again.
Now, Ernest comes from a sailing background, and most of the guys here that are capable of tying good bowlins, it's either sailing or Boy Scouts, but just an observation. I grew up among a family of sailors. My dad, during the war, was in the Navy, and they gave him the Blue Jackets manual, the survival and training manual about teaching, you as enlisted man what you were supposed to know. There were about 3 pages of knots. And I was stupid as a kid, and I looked at the old man and I said, Dad, I can just tie a triple knot, then knot it again, and then knot it again. And he taught me the next basic principle, which is, you don't understand, in the Navy, you tie knots that are designed to ultimately be untied. And that's the whole secret here. Because if you ever work with someone that's going to spontaneously recycle rope off an antenna, usually, if they haven't tied a bowline, what are they doing? Taking out a pair of scissors or a knife and cutting it at the insulator. And as you do that, you lose 3 or 4 inches a cycle. So remember, it's a good knot for holding, but it's an even better knot for getting undone. That is largely our demonstration, but I just wanted to show you a couple of formulas and a couple of ways of cutting dipole antennas. And there's always the classic question about what's the formula for dipole antenna? There really isn't a formula for a dipole antenna. What there is the beginnings of a cutting measurement for a dipole antenna. So, from your license exam, who remembers the formula?
468.
468.
The magic number.
And what,
he's a ringer.
He's a ringer. So what are we seeing here? Well, 2 of the more common bands we're going to cut a dipole are going to be what? 715 for 40 meters. 3.75 is going to be midpoint for 80 meters. My trusty calculator. Jeremy, this one's yours.
Okay.
On the 40-meter band, 7 to 7.3. relatively easy to cut a dipole that will give you about a 2-to-1 SWR max at the two extremes of the
Wait,
band.
727.3.
468 divided by 7.15.
Okay,
468
okay, 468
divided by
divided by 7.15.
0.15.
7.15. 65.454545.
Exactly.
All right. Similar calculation for 80 meters, I'll warn you, gets a little bit more involved, and here's the reason. You really can't cut a dipole to give you favorable SWR for the entire band, so you got to come to a value judgment. In the old days, you'd cut it at the center frequency, slap a tuner on it, and live with it. But today, with the redesign and the reallocation of the band, a lot of times you're either going to pick something relatively high, like the beginning of the DX window, and then going into the general band, or something a little bit low if you're more along the lines of a CW operator. So you're going to have a lot of variability in the length of a dipole for 80 meters. For the case of 30, not much at all. You cut it for 65.5 feet, and pretty much you're good to go for the entire band. Now, last thing to point out. Fred, you're disqualified. You give this away all the time. Somebody guessed the issue involved here, depending on what I'm working with. Uninsulated, more or less, corresponds to that formula. But when do you know that you have the proper length for a dipole? When you can tune it in the anticipated range. So you got your FFJ tooler, or you just attach it to your rig, key it up, and you see a respectable SWR that dips at a predictable frequency. Easiest way to do it is with bare copper wire or one of the derivatives. As soon as you add the insulation, what are you doing?
Changing the velocity factor.
You're changing the velocity factor. It's a good thing in a way. Because you know what? If you're in a situation where you've got that dipole almost explicitly horizontal, but you're lacking a foot or two on either side, this makes up the difference and eats up that foot. Now, different formulas for different kind of cuttings, but if you recognize this wire, this is your basic Home Depot twisted number 12. Used to be reasonably priced. Now the Chinese own the world's copper supply. Trust me, no wire is reasonably priced. But it's about as cheap a quality wire as you can see. But what do you notice? The purists will point out that that top layer of insulation flakes off. The thing's 100 feet up in the air. I don't care what's flaking off, would be my reaction.
Your wife does.
But when you're dealing with this guy, you've got the velocity factor to take into consideration. And this is what I do. Different wires, different jackets are going to have different formulas, but if I'm cutting this for 40, I'm going to typically do 65.45 times 0.98 and assume a 2% shortening factor. And in the context of a 40-meter dipole, hey, that's saving you a foot, foot and a half. And again, if you're short the distance between the two trees, that might get you out of trouble. If you're still short the distance between the two trees, using that insulator technique I just showed you guys to droop the last foot or two of the antenna will also get you out of trouble. Last thing I wanted to show you, though, is my favorite wire of all time. This stuff is beautiful. This is like seeing a thoroughbred horse. That's all I can tell you. Feel the texture of that wire. God help you if you try to replicate that wire today. It's probably 30 cents a foot. But if you've ever heard of wire rope, that's what you're dealing with. You could tie your shoelaces with that stuff. I kid you not. The only thing that it lacks, in other words, your flexibility, the beauty, and the malleability of it, is offset by what? It's not quite as strong as other wires that you're going to have. But it's really good stuff when you have a piece of wire that you might want to use again and again for different purposes. Because literally, to put that through an insulator and wrap around is no strain whatsoever. Instead of soldering it into position, you can literally tie the knot, and the thing is not going to move out of the insulator. So, that is our little demonstration. I thank you for attending. Someone draw 100 points on the flip chart.
Yeah.